Already we considered how we could solve three coplanar forces in equilibrium by using triangles of forces. This time, let us see how we can use Lami's theorem to solve three coplanar forces in equilibrium. So we can see three forces here, three coplanar forces in equilibrium, A, B, and C with the angles between them. And we can illustrate this in a triangle as you can see. Then let's also show the angles between the forces. So between A and B we have lambda. So this is force A and B, we have lambda. Between B and C, so B and C we have alpha. So we have alpha here. Then between C and A we have beta. So we have beta here. These are exterior angles that we can convert to interior angles like this. Then you recall that the sine rule says that A over sine of the angle opposite to A is equal to B over sine of the angle opposite to B, which is equal to C over the sine of angle opposite to C. And applying the property of sine, we have sine 180 minus theta equals sine theta. That gives us sine 180 minus alpha equals sine alpha, and so on and so forth. So this is the Lami's theorem. So it's simply saying that if you have three coplanar forces in equilibrium, three coplanar forces acting on a particle in equilibrium, what we can do is A over sine of alpha. That is the angle directly opposite to that force. Then B over sine of alpha, sine of beta, C over sine of lambda. That is what you're seeing here. Let's apply this to solve a question. A body of mass 20 kg is suspended by two light inextensible strings, XP and YP, which are inclined at 30 degrees and 60 degrees respectively to the downward vertical. Find the tension in both strings. Take gravity due to acceleration to be 10 meters per second squared. So we illustrate this in a diagram like this. So we see the inclination to the downward vertical 30 degrees and 60 degrees from X and Y, from point X and Y. We can see XP, the string XP and YP, and the tension, which is the force in the string, is T1 and T2. Then we have the weight here, which is the third force. So we have three forces in equilibrium. Now, we can also find this angle to be 30 by alternate angles. This will be 60, alternate angles property. So this tells us that the weight will be mg, which is 20 times 10, and that will be 200 newtons. So this is the weight. Then the angle here will be 90, and since this is 60, this is 30, this will be 60. So 60, since this is 60, this will be 30. So adding 30 to 90, we get 120 here. So that is why we are looking for the angle between the forces. Then we also have this angle being 30, so this will be 60. So 60 plus 90 will be 150 degrees. So the moment we get the angles between the forces, 90, 120, 150, we can apply the Lami's theorem. So with the Lami's theorem, we are going to get 200 newtons, this over the angle which is directly opposite to it. 200 over sine of that angle, sine 90, will be equal to, so sine 90 degrees will be equal to T1. So T1 over the force directly opposite to it, that is sine of that angle. So not the force, but the sine of that angle. And sine 120 is the same as sine 60. So this will be equal to T1 will be equal to 200 sine 120 over sine 90. Sine 90 is 1. So this will simplify to 173.2 newtons. So that is the first tension. Then we can also use the Lami's theorem again to find the second tension. So T2 over sine 150. So this force over the angle, sine of the angle directly opposite to E, will be equal to again 200 over sine 90 degrees. So they are in degrees. So this implies that T2 will be equal to 200 times sine 150, which is the same as sine 30, all over sine 90 degrees. And this will simplify to 100 newtons. Remember that sine 150 is half 100 newtons. So we found the two tensions. Find the tension in both strings. That's what we found. 100 newton for T2 and 173.2 newtons for T1. Now let's consider the second example. The diagram below shows an object of mass 5√3 kg held at rest by a horizontal force F Newton and an inextensible string inclined at 30 degrees to the downward vertical. Calculate the horizontal force F and the tension T in the string. So let us first of all calculate the weight. The weight will be mass times gravity due to acceleration, which is 5√3 times 9.8, and that will give us 49√3 newtons. The angle here will be 30 degrees. So adding 30 to 90, that will give us 120 degrees. So our focus is to find the angles between the forces. So the angle between the tension and the force F is 120. The one here is 90 degrees. So we can calculate the tension. So we know that T over sine of the angle opposite to it, which is 90, sine 90 degrees, will be equal to the weight, which is 49√3 newtons over sine of the angle opposite to it, which is 120 degrees. So T will be equal to sine 90 is 1. So T will be equal to 1 or sine 90 times 49√3 all over sine 120 degrees. And that will give us T is equal to sine 120 the same as √3 over 2. So the whole thing will become 49√3 all over √3 over 2. So this will simplify to 49√3 times 2 over √3. So this will cancel this together to give us 49 times 2, which is 98 newtons. So we could also calculate the force F. We know that the angle here is 30, so the one here will be 60. So we add 60 to 90, and that will give us 150 here. So we have F over the sine of the angle opposite it, sine 150 degrees will be equal to 49 root 3 over sine 49 root 3 over sine 120 degrees. So this will give us f to be equal to sine 150 times 49 root 3 all over sine 120 degrees. They are all in degrees. So we can simplify further to obtain sine 150 is half 1 over 2 times 49 root 3 all over sine 120 is root 3 over 2. So this will simply get rid of this, and root 3 will also get rid of root 3. So F will be equal to 49 newtons. So F is 49 newtons and T is 98 newtons.